Hey, and welcome back to another Tech Day live. This one is not live, I'm actually recording it ahead of time. The first thing I want to do is to talk about disks and file systems again. There's my tablet. I I prepared it this time. It's centered, it's a bit bigger. Hopefully it will I don't know, be okay from a viewing perspective. Let's talk about disks and file system because I realized the book that I'm reading, the book that I'm following. So the book mentions dev SDA because that's the classic naming convention for SCSI style block devices. It includes SATA and USB disks under the hood. My system, on the other hand, doesn't have a dev SDA, and that's normal. So why? Where's my terminal? Let me open it. Let me open a new window. Let me put maybe here. Why? Because I don't have a traditional disk. Because modern laptops like mine ship with NVMe SSDs, not SATA, and they use a different naming scheme. So if I type in lsblk, here it is. This lists all block devices, and I see something like this. If I would now plug a USB stick, I don't have a USB stick here around me, do I? Maybe I do have. Oops. Maybe I do have a USB stick. Let's see. No, I don't have. Note for myself in the future, prepare better. So I don't have a USB stick here. So what is happening here? Dev SDA is the first disk the kernel discovers because these are the ones on the older systems. On modern ones, I have a gaming laptop, I think. It's NVMe. It's the same concept. It's the same concept. I can do dev SDA, which I don't have, or NVMe 0. I think I have 2 and 1. Yeah. This is the whole disk actually, and these parts here, as you can see, P1 and P2 are partitions. All of this. So SDA is the old school. They are block devices which are detected by the kernel's SCSI subsystems. Those are mostly rotational hard drives or SATAs. I remember those ones. I used to repair a computer of mine, and I had this SATA disk. But NVMe is the modern memory type. It's non-volatile memory express. It's built specifically for SSDs, and it skips some bottlenecks that SATA had. Now, what specifically are partitions? Partitions are sections of a single physical disks. Basically, we take a single disk and we slice it into smaller logical chunks. And if I type here again, where are you? ls, you can see all of these sections here, all these partitions actually. This is partition 1, this is partition 2. Some of them might be the Linux root file system, some of them might be swap space, homes, whatever, users. So why do partitions exist historically and practically? Because first of all, historically, on old machines, early BIOS system could only boot from the first part of the disk. So we had to keep a boot partition near the start. Now, another reason is because what if we fill one of our partitions? If we fill up your user partition, home, fills up. If our system files were on the same partition, our system could crash. So we isolate the root partition and home, or the user ones. And the operating system still runs even if our files eat all the space. We could also dedicate a partition for swap space, which is the virtual memory on the disk. This is faster and more reliable than just using a swap file on the main partition. We could even do multi-booting and things like that. I showed you how yeah, these are our partitions, and I assume this is the boot partition, yeah, and this is our second partition. Now, what's the difference between a partition or a file system? A partition is a container, which is a reserved region of disk space. And the file system is the content system, how files and directories are stored inside it. For example, some of the most common Linux file systems are ext4, xfs, ptr, fs. For Windows, I think you definitely heard about ntfs, which is a Windows file system. And if you ever did some work on your USB, like did a factory reset or cleaned everything, you definitely remember FAT32 or xFAT. Now, if I do, let me clear this. lsblkf, we see the partitions here again. And we can see the file system of these partitions. Now, what else do we have? Yeah, swap space. I mentioned swap space, which is the disk space, which is used as extra memory when our RAM runs out. Linux is saying, all right, we don't have enough RAM, there's not enough memory. So let's temporarily move some stuff around so we can free up RAM for active processes. Now, swap is much slower than RAM, because even if we have these fast non-volatile disks, they are slower than memory chips. But having some swap could be a good safety net. Again, oh no, I didn't want to do this. I wanted to do this. This is our whole NVMe disk, the whole device. The first part that contains 1 GB is the small partition for boot files. Our firmware on our laptop will read bootloaders for here, like grub, for example. Now this is my other part, but there's something wrong here. This should be mounted as root file system. Wait, let's make some sure. No, it's still here. Wait, what's my real mount? Find them in mount. Yeah, so this is my actual root file system. And let's see this. Let's see all the mounts. Okay, so here are all of my mounts. I have the default one, and I have these other ones that does some snap trickery. So I don't need to fix the disk itself. I think my root is fine. What I should do now, let me paste this. and LSP. Okay, wait. So let me also check my boot configuration here. I don't think I should do anything. I don't want to break anything, but I believe that nothing is broken. It's just misleading output because Snap added an extra bind mount for Firefox dictionaries, and LSB LK got tricked into displaying that instead of the root. Yeah, this is how Snap, at least Google said, this is how Snap behaves normally. Let me just try to Google this. Let's see what I get. Oops. Root partition mounted on slash. I rebooted Ubuntu today and could not find the root drive, and I keep running the root shell. What's this? Ah, below command removes the extra binding instantly. Okay. The dual binding is not bum. Bum. And then if I run this again. Alright, now I'm on root. Okay, we fixed. As syndicated over at Snapcraft forum, this mount is set up to allow Firefox Snap to use the spell check dictionaries of the mail system. A discussion about this commit is available here. Allow access to handspell dictionaries for spell checking. This commit is a step to address this bug. So there's a bug here. What do we have here? Initially reported here. When was this? 4 years ago. Strictly confined snaps cannot see spell checking dictionaries installed on the host system. Users have to explicitly download spell checking dictionaries from about add-ons. So what was the change? Allow access to handspell dictionaries for spell checking. Right. Unfortunately, this PR does not work as intended because user/share inside the strict mount namespace will come from the base snap, which does not have these files. How is this not a security vulnerability? If Firefox is compromised, this is actually a good question. Cannot a malicious actor gain read access to entire root file system? All right. Let's continue. As we said, partition table is like the map of the land. I can say these are my partitions. I can say here I can say it in terrible drawer. Let's say this is 0 and this is 1 million. Imagine that there are multiple blocks here. From block 0 to block 1 million, I can call this partition 1. I can select this, copy, paste. This should be 1 million, 1 to 2 million, and let's call this one. I don't want to overwrite this. Let's do this properly. This will be partition 2, and so on. From block 2 million 1 to 3 million can be partition 3. Now, once we decide what the boundaries for the blocks are, we can decide how to organize the contents inside. Let me see. Let me clear this. And let's do a couple of examples. If I do sudo parted L, okay, I need to type in my password. I should see my partition table. So partition table GPT confirms okay, so I can see my partition system. I will explain this a bit better right now. So this is my model here. And this is my whole disk, which is my first NVMe controller, and N1 is the first namespace, because these disks can have multiple namespaces, which are virtual drives. Sector sizes are the smallest unit of the disk that the disk actually works with, and these are 512 bytes. Both logical and physical are the same here. We have the partition table, which is the modern partitioning scheme. GUID partitioning table allows, I think, 128 partitions, and it also works with large disks. So what do I have? I have my first partition, which is a tiny slice at the start of the disk, which is around 1 gigabyte, which is, you know, a system boot partition. What else? The file system is FAT32. It requires FAT32 to boot. Yeah, here it says it's a boot and a system partition, FE system partition. The second partition takes the rest of the disk, which is basically my whole system in storage. It's my Linux root partition. Okay, so this is maybe one example that we did. What else can we do? What else can we do? If I do sudo fdisk l dev nvmeon1, here we actually can see our sectors, and the numbers are bigger. The numbers are bigger because the units are in sectors. And if you remember here, the sector was, no, not here, 512 bytes. Now, let me try to do this again. Let's do sudo fdisk l dev. Is it input? Input event is 9. It's not 9. 10. Nah. Okay, I'll find where my mouse is. But first of all, fdisk. Fdisk is the traditional disk partitioning tool on Linux. So this is the traditional disk partitioning tool. Wait. The L flag means list partitions. So this will actually list all of the partitions on the disk, this command that we run right here. One thing that you can notice is that the actual size of the disk is 477 gigabyte. I don't know if this is the marketing or what it is, but it shrank down a bit. Also, here, it's measuring sectors. If you remember this amount of bytes we have, so if I copy this calculator, and if I do this and I divide it by 12, I would assume I will get, right? No, not by 12. Wait. Remove this. If I divide it by 5, yeah, 512, I get this number right here. What else? Yeah, here I have the size of the sectors. This is performance related. I don't know what this means. This is my disk identifier of the table itself. The partitions, as we said, we have the first partition, which is for the bootloader, the second one, which is for our Linux root file system. Fdisk doesn't work on events. That's my bad. It only works on block devices, because my mouse is a character device. It's not a disk. So what I would need to do is plug in an USB, which again, I don't have. I should get one to do this properly. Now, I could also talk about modifying partitions. I won't do any, I mean, I will talk about it. I won't do anything, because partitioning is really destructive if I'm not careful. Because if I change and delete entries, my operating system wouldn't know where data is anymore. So I should have a spare USB stick, which again I don't have. I should buy one, and then I will experiment. But what I could use I could use the fdisk that I've been using right here. Fdisk also stages our changes. It's good for learning, and there is also parted command. It's faster but riskier for newbies. Let me try to find a USB somewhere. Wait. Well, I have a problem. I found one, but all of my connectors are plugged in on my laptop. I have my mic, I have my external mouse, my keyboard. So, and the thing is, this one is custom made or something, so it's quite wide. Yeah, that's what she said. So it can fit here. So either way, seems like, oh, there's another one. Let me try this other USB stick. Okay. Now I have it. Let me just try it out. If I do this command again, but instead of this, I use SDA. Huh. What kind of USB is this one? What the hell? Why do I have 4 partitions here? Why do I have both Linux and Microsoft here? Yeah, I know I have multiple partitions here. I mean, it says it doesn't technically contain Windows, but it's still like 5 gigabytes. It must contain some sort of it contains something heavy. Alright, this is my FE partition. It stores bootloaders. So it's definitely a bootable USB. I remember this. But let's confirm what's inside. Let's confirm what's inside. Let me clear this. ls blkf dev sda. So this is gonna list the file systems. So I do have Ubuntu here. All right, let's run. Let me see what's here. Sudo make directory p mount sda1. Sudo mount sda1 mount sda1, and let me now see what's here. So again, I have the whole device here. My label is the Ubuntu. All right, 2404. So the entire USB drive was written with a Ubuntu installer. ISO. This must be, okay, I think I know what this is. Balena? Do I have Balena actually installed? I think I have. So Balena, so it still says it's Ubuntu. Okay, I have the first partition. This contains read-only ISO data. It's 100% full, I think. Yeah, it's 100% full. So this is where it's mounted. The second partition is the system partition. So it's a boot. It contains a lot of bootloader binaries. It's super small. The third partition, it's empty. And the fourth partition is a persistence partition. So most probably, because it's writable, it's persistent. I think I know, I remember now. I had troubles with my laptop some time ago. This was like 2-3 years ago. But no, it's not 2-3 years ago if I have 2404. This one happened. Yeah, now I remember. I had a work machine and I tried installing Linux on my own because we were using Linux for work. And for some reason, I couldn't do it. My machine was telling me that it couldn't find the bootloader. So the company told me to send it to a guy who fixes this, and he did something. And to be honest, he did charge a lot. He did charge a lot for something that I could have done if I had more time to inspect and experiment. But yeah, what can you do? Yeah, I think I can see all the installer files. If I do ls media, my username, Ubuntu, yeah, these are all the installer files. Oh, let's do mount dev sda2 mount. If I do this is the fe folder. Fe. Wait, can I even enter it? Ah, because I need to go here, and then fe. What's the name? Boo. Ah, it's lowercase. So if I do get bootx 64 f. All right, so we have 3 files here. This is right inside our FE system partition in our USB stick. The first one, bootx64.efi, is the default bootloader file. So the UEFI firmware will look for this file when booting a removable drive. x64 just means that it's designed for 64-bit systems. It's the entry point for the UEFI boot on our USB stick. This is our grub that is compiled. If I remember, can I even see grub? No, I can't see any of this. All right. No. It gives us the boot menu when we can do try Ubuntu, install Ubuntu, and other things. This is the machine manager shim binary. It's used for secure boot. I don't think I can read them because I said I can't read them. But can I inspect them? Executable. What? Why is this unexecutable? Okay, let me just find why this is unexecutable, and we're gonna skip to another subsection. Let's talk about file systems. So why is my Linux boot file on Microsoft Windows executable? Basically, FE files are executables for UFP firmware. They use this executable format, which is the same format of Windows X files use. Why? Because Microsoft worked together with Intel on these specifications. They decided to reuse the existing Windows PA format to standard binary format for programs. Yeah, it's now every binary, whether it comes from Microsoft Linux or I don't know, anywhere else, looks like a window program to the file command. Now, let's talk about file systems and what file systems are. I just need to put my screen copy centered, and I'm gonna write here file systems. So a file system is a way to turn all this disk stuff, like devices, partitions, block storage, into the actual files and folders that we use every day. So a file system, let me navigate. A file system is a data structure on a partition that organizes raw disk blocks into files and directories. What the disk is something similar to a to notebook, an empty notebook. Now, partitioning would be drawing boxes inside this notebook. This section we are going to use for notes. This section we are going to use for math, science, algebra, I don't know, stuff like that. And file systems is deciding how you write things in those boxes, deciding what markers to use. Should we paint it with something? What colors? Things like that. Because without a file system, our operating system just sees raw blocks, which is more or less useless gibberish. There are some file system types. The most important are, I'm just gonna write them here. X4, ext4, fast, reliable, good against corruption. We also have btrfs. It's more modern, more complex. We have FAT. If you remember in the USB that we just checked, it's used for USB sticks, cameras, cross-platform compatibility. I think there's a limit to it because it's older. It's around 5 gigabytes file cap. Now, Windows one is called NTFS. I think Linux can read and write NTFS. Don't hold me accountable for what I said. ISO, if you ever burned images onto your CDs or DVDs, this is used for CDs and DVDs. And so on and so on. I could now create a new file system. I don't want to do this because it's destructive, because it will destroy any old data and it will create a new structure. So I won't do this. But if you want it, if you want to learn about it, you can do this. I will maybe just explain what this Linux file system is. It's called X4 or fourth extended file system. It's the evolution of X2 and X3. And if I'm not mistaken, has some backwards compatibility with it. X4 is designed specifically for Linux. There are some key features, like there's big file support where a single file can be up to 60 terabytes. It's backwards compatible. It actually keeps a save state of your data before writing them. If our PC crashes mid-write, X4 can actually recover your files. Now, what I could do, again, I don't want to do this because I'm afraid I'm gonna break something. If you remember, I think I did a command called dd, which is a low-level copy tool. It will read from an input and it is going to write to an output file. So the command I could write is ff dev. First of all, let me move this here. dd if dev 0 of x test image. I will do this and I would do this. What my input file, I just need to remove the f at the beginning. What my input file is a special device. If you remember, we talked about devices that outputs an endless stream of zeros. It's an infinite blank tape, so to say. And the output file is this image. This will become our fake disk. If I would create this, this would become my fake disk. My block size is 1 megabyte. I would make 100 of those, so it would be like, what? 1 megabyte times 100 megabytes. What would happen? We would create I don't know how to call it, an imaginary empty hard disk. We would just create raw sectors and write it to this right here. If you remember, wait, can I do dev 0? Can I ls dev 0? Wait, clear ls. No, I can't. But basically, it's a stream of only zeros. And then I could check the file and I could inspect it. I don't want to do any of this. I don't want to break anything right now. So mounting, I'm gonna skip mounting. Oh, I could talk about swap space now. Actually, let me just do this before. Even now, I have an external hard disk that I'm using. It's actually a pretty cool one. Has all my pictures and stuff. The problem with it is that every time I need to mount manually my things. I tried researching why this happens and how this happens and what I can do. But to be honest, I didn't find a viable solution. So the thing that was happening is that most probably I didn't have a proper configuration file on which file system to mount, where, and with what options. Because I had to run manually mount every time I boot. And if I do now etc fstab, what do I have here? So each line is one file system, and I currently have only the swap. Do I have anything else? Again, I would need to create a what's the name? A fake disk space. I don't want to do this. Sorry. Sorry. So I think I'm gonna skip all of this for now. Okay, swap space. Usually I don't what swap space is. Again, I'm learning this. I'm only picking up the big pictures. I don't want to do. I don't have the time to go that deep. So swap space, as we said, it's extra RAM on disk. When our system runs out of physical RAM, Linux says, we are not using the memory. Let's dump it onto the disk so I can free up real RAM, and that's called swapping. But SSDs are slower than RAM, so swap saves us from crashes, but our system is really slow if we do this. And how can we check it? Let me just write this. Oh, okay. I'm not using any. I have 62 gigabytes, so I'm not using any for this. I could actually create swap of my own. but I don't think I need it. I don't think I need any of it. But let's do do I have stress ng? No, I don't want to use this. Okay, that's it. What else can we talk about? Okay, let's skip. Let's stop this now and let's do something else. If I do go here, hacker news. Let's see if there are any interesting. Oh, this is too much. The beginner sample for fully homo. Okay, I thought it said something else. Past. A tiny little JSON parsing library in 150 lines of C99. So what I'm doing now is I'm just checking for some article that I might find interesting. Another place where I also like to see the newest technical things is a certain image board. A certain image board, because they have a lot of good discussions there. I'm gonna do this as well. A tiny little JSON parsing library. 150 lines of C++. 0 allocations with minimal state, error messages. Oh, how does it work? What I love about this author's work is that they are usually single file libraries in ANSI or Lua with focus scope, easy to use interface and good documentation, and free software license. Also, okay, so the author is actually providing a lot to the community. The library doesn't check for signed integer overflow here. I'm not aware of the simplistic single header C library culture that some developers like to partake in. Coding. I know this guy. A streamer is a prime example of someone who likes developing using these types of libraries. They acknowledge that these things aren't focused on security or features, and that's okay. Let me open this again. And that's okay. Oh, shit. Not everything is a super serious business project exposed to thousands of paying customers, which makes a lot of sense. This guy thought he had something there, but this is actually pretty cool. I don't care about this. This is rather lenient. There's not anything wrong with that, although perhaps it shouldn't be noted for people that will use it without looking at the code. But the main reason this can be so small, using their demo in the README. JSON parser libraries are usually. So what SJ is basically, it's a single header C library. So let me open it here. That parses JSON, and that's it. SJ probably stands for simple JSON. It's in public domain, and it has like what, 150 lines of code, 156. Basically, when someone says tiny JSON parsing library, they usually mean it's small, like this one is. It doesn't have any dependencies. It doesn't use a lot of memory. It has simple functionality. The thing that these guys here have said, that there are some edge cases. It may not support every edge case, every feature of JSON, of related extensions. It might, I don't know, skip some things, blah, 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 blah. no string parsing, no number parsing. So it's small and simple. It's easy to drop into existing code. Maybe I could. Why is responsible adult SimCity 2000 hits differently? Okay, I'm gonna read this as well. But let me just check this. So this file, it's a header only JSON parsing library. We can include it as just one file. If we want implementation, do we even have implementation? No. Demo, this is a demo. I don't care about the demo. So basically we have some declarations here, like the readers and the value. We have some enums. The reader is the state machine for parsing. So these are the buffers, I assume. This is the depth. I assume this is the error. What's this? This is a string token, JSON token. What functions do I have? Okay, this is how I initialize a reader. This is how I initialize a value. This is reading the next JSON token, seems. I think this is similar. I did actually implement a parsing language of my own, a pretty simplistic one. So I think okay, let's come back to it. Let me just see this. When I was a child, I Instagram instead of Xcode. What's Instagram? I don't know what this is. I'm gonna just kill it. Let me read this. Oops. Okay, Ars Technica, please check this article. Why as responsible adult SimCity 2000 hits differently? After years as a parent and homeowner, I sympathize more with my virtual citizens. Oh, this is cool. Seems like they are gonna review a retro game every fortnight, most probably. Really cool. What are some other things they mentioned? Is the Elder Scrolls Daggerfall a good game? The Remembering Descent, the one popular fully 3D. I also heard about this. Is Daggerfall really a good game? Is this a big article? Okay, I'm gonna read this as well. SimCity was a fun animated set of urban themed Lego blocks to tinker with. Revisiting the game 3 decades later, or roughly 3 decades later, so it was what? It was created in 94. It's 94. Why did they call it SimCity 2000 if it was 95? I mean, it looks kind of rudimentary, but also what else has GOG in the store? Good old games. Oh, Diablo. I love this game. This is probably my favorite game. Ooh, Deus Ex, and they have it for only $3. Also, why is Vampire the Masquerade Bloodlines expensive? It's like, what? $20 for a 20-year-old game. Alright, doesn't matter. The tough economics of establishing a thriving city barely concerned me as a child. Rather than building up a durable tax base from slowly growing city of happy citizens, I usually type in an infinite money cheat like a yeah, I did it in Sims or in San Andreas. Or load up the hand. Okay, so this is more some expansion. SimCity arcology. What's an arcology? Ah, so okay, so it was probably a special building. So he was building arcologies. He had infinite money. Yeah. He also did some sociopathic tendencies. But okay, so as you grow up, you change the way you think about these imaginary virtual people. I think nothing of temporarily cranking up property taxes just to pay for a pet project. Now it makes me think of my own slowly rising. Yeah, legalized gambling. Shit, they also had this as well. Today, when I hear about a lot of games are like this, a lot of games, a lot of movies as well, hit differently as you grow up, and you have a different artistic interpretation, not only artistic, personal interpretation of them. Playing SimCity 2000 as an adult forced me to sit and think about what I consider. Can I learn my values by sparing some money in a tight budget for homeless shelters or anti-smoking initiatives? I love this game, even though I never played it. SimCity is one of the biggest reasons that I became a civil engineer. Now this is cool. I really love this. I can't upload 95 comments. Can I see all of them? What the 10 years ago? When was this written? This was written. The user was created 10 years ago. Yeah, also GOG is a great site. I love the GOG partnership. Yeah, GOG is a great site. Okay, I'm gonna skip this and so this is the JSON text. See the demo. Yeah, but can I run the demo, man? Okay, let's download it. So let's do a test. Done. Okay, where's my terminal? Not the calculator. No, what hell? All right, we are here. Where am I? CD downloads. SJ. Is it downloads? So it's zipped. So what I need to do here is to extract it. like, I think I can use unzip. Do I have unzip? I have unzip. SJH master. Only these files here. Then I go SJH master, and now we are here. What do I have here? Okay, let's actually do to demo. Let me increase this. Let me open Vim array. Okay, let me close this, and let's now do pcc std c99, right? All output array.c array cat, dog, fox, and owl. Cat no, oh shit. Cat array.c. So it demonstrates iterating an array. Alright, so I import all of these classics. I import my sj.h. This is my JSON text. This is my JSON text. Okay, so I just create a reader for my JSON text and the length of my JSON text. That's my array. While sj iter array, where's this guy coming from? Is this coming from the library here? Most probably. Okay, so this is a string literal in C. What happens in memory, this is just a sequence of characters. But you know, it's C, so we need to represent it as an array of characters terminated by an null byte. This is just an array, as I said, of characters. But when we assign it to a variable, we need to point it to the first character here. So that's why JSON text holds the address of the first open bracket here in our JSON string. Here we just make a reader. Here we read this array. And sj iterates array, so it's gonna skip. So it's gonna iterate through the array elements one by one. And each value, where is the value? Is this guy here, right? Okay, so here it prints it out. Okay, so val is an element. It can hold one element at a time. It might represent dog, cat, what others. So here I'm actually looking at the address of val. Because this method most probably expects a pointer to it. What will happen is most probably this function will fill into the next element, into the next array element. I love it. Okay. Now, let's do something else. Let me close this. And this, I can close it. As you can see, the title of my note here is called ML, or machine learning. I didn't do it in a very long time. So today we are going to continue with ML. So let's talk about some concepts. Let's talk about a particular problem we might face with machine learning models. And let's see how we can fix those problems. Let's say we have a machine learning algorithm, and we want to apply our machine learning algorithm. So let's say we have a machine learning algorithm. Different problems require different applications, so to say. And one of them is, as you already know, linear regression. So we want to apply linear regression. We need to build a machine learning model for a data set of customers. So what is a machine learning model is what we get after we apply an algorithm to data. So linear regression applied, and you get machine learning model. That's basically a trained result. It's a function that takes new data and outputs predictions. Now, why could a model fail? Possibly. Something might go wrong. So things might go wrong. What could happen? Actually, this is quite a common thing, because a lot of things can go wrong. Two problems when training models that happen often are underfitting and overfitting. So what is and what are these two concepts? What do they mean? What is underfitting? What is overfitting? Let's say we study for a test, and some things might go wrong during our study procedure. Maybe we didn't study enough. We can't fix that, and likely we are going to perform poorly in our test. There's also another scenario in which we studied the exact amount of time or even more, but instead of learning and understanding it, we memorized the entire textbook word by word by heart. So what happens in the test? Well, probably not a good thing, because we simply memorize everything without learning. Basically, underfitting is like being lazy. The model is too simple. It just ignores the actual patterns. On the other hand, overfitting is like being obsessive. The model memorizes everything, even the noise, and fails when the test data looks slightly different. So we need a good sweet spot, and a good sweet spot is in the middle. It's a model that learns the real signal, but doesn't get distracted by the noise. For example, let's do another thing. Imagine you're dating. You are on a date. What is underfitting in this context? You barely pay any attention. You don't listen to the other person. You don't notice what the other person likes or dislikes. You go to another date. The second date is also awkward because you as a person never adapt. Basically, you are too simple. The model is too simple. You don't capture any patterns. Then you have overfitting. What could overfitting be? You stalk their social media. You follow them everywhere. You memorize everything about that person. You go all the way back to 2011 when they just created their Facebook or whatever. And you say stuff like, oh, in 2011 you went to this, I don't know, high school and you liked chocolate milk. And then in 2015 you said you are lactose intolerant. You memorize a lot of noise, and that might be a bit creepy. You know, underfitting again is having a complex problem, and the tool we are trying to solve this is very simple, basic, and it's gonna fail. And overfitting is on another edge or on another level of, and it's completely diametrically invert from underfitting. The problem is simple, but the tool is too complex. Let me just do a quick refresh on the concept of parameters and hyperparameters. Parameters are learned from the data during training. They define the model's internal state, and the algorithm adjusts them automatically to minimize errors, like the weights and biases in linear regression. That's a parameter. On the other hand, the hyperparameters, I need to write this, parameters versus hyperparameters. Hyperparameters are set before the training by the practitioner. They control how the learning process works. They are not learned by data. They are chosen, tuned, or searched for. For example, the learning rate or the number of neighbors in a KNN algorithm. It's basically parameters are the skills you, if you're playing a role-playing game, these are the skills you develop, like strength, agility, intelligence, charisma, luck. And hyperparameters are, what computer do you have? Is it fast enough? How many hours a day are you dedicating to playing your video game? What are you eating while, what have I clicked here? Okay, what are you eating while you are playing this game? And stuff like that. So let's do an example. Let's do an example of underfitting and overfitting using polynomial regression. Let's say we have the following thing. The following dataset. Let's say I have something like this. Okay. So we can think about it. What kind of polynomial would fit this data set? Could it be a straight line? Maybe a cubic formula? A polynomial of a higher degree? If you remember, the degree of the polynomial is the highest exponent present. So if I have x10 plus 5x5 minus 2x plus 1, the degree of this, because we have the 10th here, would be 10. Wait, let me just change these colors a bit. Okay, I have blue, pink, and blue, pink, and oh, let me just clear this. I have blue, pink, and green. So how does this? How do these data points look like? They look like a parabola. It opens here somewhere, and it goes down. Something like this. Something like this. So the polynomials that look like this are polynomials of degree 2. You know, we can look at this and we know that it's a polynomial of degree 2 because the points follow that shape, but computers, the computers can't know that properly. So a computer needs to try many values for the degree of the polynomial and somehow pick the best one. And we can try testing this with the polynomials of degree 1, 2, and 10.